Hey, I want to tell you about the history behind determinism so you really can understand where this is coming from and you'll better understand the absurdity of the idea. So, Aristotle believed that the world was composed of two different regions, the superlunar and sublunar. Down here, things fall down and things go up like smoke and fire. So, natural motion is in the vertical direction. I mean, yes, you can throw things sideways and the wind blows sideways, but that's violent motion. Natural motion is up and down, but up in the sky, natural motion is, of course, sideways. The sun, the moon, the stars, the planets go sideways. So, and of course, down here, things are in decay. Up there, everything is perfect and ephemeral. So, Aristotle divides this system, his physics, which had the superlunar realm up there and the sublunar realm down here. The laws of his physics were different in those two different regions. Okay, fast forward to almost 2,000 years. In the 1600s, Isaac Newton was sitting under an apple tree. An apple fell down while he was sipping his tea. And he thought, now he had done a lot of work before this. This wasn't just out of nowhere. But it dawned on him that the apple and the moon shared something in common. And what did the apple and the moon share in common? The acceleration. They were both accelerating toward the center of the earth. So let me draw that here. So here's the Earth, and here's the moon, and the moon, of course, is going sideways, and it's going to go around the Earth. The apple is going down. So obviously their velocities are not in common. The apple's velocity is down, the moon's velocity is sideways. But the moon, because it's circling the Earth, is accelerating toward the center of the Earth. If it wasn't accelerating toward the center of the Earth, it would just keep on flying off into nowhere. But because it's got a little bit of an acceleration toward the center of the Earth, it bends the velocity vector down this way, down this way, down this way. It's constantly accelerating toward the center of the Earth, but never going there. It's always going in a circle around the Earth. That's circular motion. You learned that in your high school physics. So the moon's acceleration is toward the center of the Earth. The apple's acceleration was toward the center of the Earth. It went from sitting there on the limb with zero velocity. It built up a velocity and fell to the ground. Newton figured out that there's a gravitational effect, and he called it a force. So there's this force of gravity that is causing the acceleration. And so you remember from your high school physics, F equals ma, right? He also had the universal law of gravity and the universal force of gravity. That word universal is important. Why? Because he overturned the sublunar, superlunar dichotomy, the Aristotelian realms of superlunar and sublunar realms gone. Newton unified the world. And it's hard to overestimate the impact of Newton's findings, Newton's theory, Newton's new physics. We call it Newtonian physics or classical physics, overthrew Aristotelianism. And it was really changed the way people thought. It was, up until then, there was a certain mystery about the way things worked, especially up in the sky. Why did things move the way they moved? He explained how the solar system works, how the planets move around the sun, and so forth. And it made people think that the laws of nature really were in control to a certain extent. You could take that away from Newton's physics. The laws of nature explained everything. They were explanatory. Newton wrote this up in a famous book here. I have this book here. Well, of course, this is the English version. He wrote his book, The Principia, in Latin, of course, but this is one of Newton's books where he went through his physics, famous book. But so there's the famous revolution of Newtonian physics, but amongst all that there was a problem. Newton had a problem, and let me explain to you his problem. Newton, like I said, explained how the solar system worked. You have the sun in the middle, and you have the planets going around the sun. There's Mercury. Here's Venus, Earth, and so forth. Mercury orbits the sun in about once every, say, 3 or 4 months. Venus every 6 months or so. Earth once a year. So these planets are circling the sun at an increasingly slower rate as you go farther out. Of course, once every 4 months or 4 or 5 months, Mercury is going to catch up to Venus. So let's say Venus is here, Mercury's going faster, it catches up, and you have a planetary alignment. The Sun, Mercury, and Venus are aligned. Every once in a while, that's going to happen when the Earth is here. Venus has caught up to Earth, and Mercury has caught up to Venus, and you have a bigger alignment, and so forth. This can happen with Mars. Now, as you add more planets to this, it happens less frequently. The Mercury-Venus alignment might be once every 4 or 5 months. The Mercury, and I'm making these numbers up, don't quote me on these. Mercury, Venus, and Earth alignment might be, once every 20 years or something, whatever. Again, I'm making these numbers up. But the point is, every once in a while you get these alignments, and you get all the planets aligned up, once over a long period of time. When that happens, it's rare, but you're going to have the gravitational pull of all the planets aligned. And that, Newton realized, could perturb this machine. Newton had explained how the solar system works elegantly, explained what we were looking at, but there was a problem. Every once in a while, you'd have these alignments, you'd have perturbations, and it could induce chaos. It could induce instabilities. And for Newton, this meant the solar system was not long-term stable. There was a instability looming, and in fact, Newton wasn't exactly sure why we were around right now. Why was the solar system even working right now? It should be long-term unstable. This caused a problem, a religious problem for people, because it implied that God had made a world that didn't quite work right. God made a world that had a long-term instability built into it. And that, for many people, including Anglicans and Lutherans, caused a big consternation. There was a Anglican cleric named Thomas Burnet who thought about this, and he made this analogy with a clockmaker. Imagine a clockmaker who makes a clock, sets it down, but the clock doesn't do anything. The clockmaker has to move the hands once an hour to keep time. Another clockmaker makes a clock, sets it down, it works. Clockmaker sits back, the clock just works. Now, Burnet asked the question, who's the greater clockmaker? Obviously, the second one is the greater clockmaker. Okay, now take that analogy to God. Who's the greater creator? A creator who makes the universe that, he has to go in there and move the hands every once in a while, figuratively speaking. He has to do things to fix things up. There's stabilities that need to be remedied every once in a while, instabilities. And then you have a creator who creates a universe, and it just works. He sits back, and it just works. Burnet's argument was obvious. The greater God is the God who makes a universe that works by itself. And this logic might seem very obvious to us and intuitive. Yeah, it's a good point, right? Seems logical. Well, it's going to go wrong, and I'll explain that in a minute. But keep that in mind, the greater God hypothesis, the greater God theology. Now, back to this problem of the instability of the solar system. Like I said, there was a great need to solve this problem. It caused religious consternation, the specter that God would create a world, a Newtonian world that was unstable. And so a century later, that problem was solved by Pierre Laplace, a great French mathematician and scientist. And Laplace looked at this and studied it hard and came up with a solution that said, those problems, those perturbations that Newton identified, they iron themselves out. They are long-term stable. Yes, there are some perturbations, but they die out. They decay. No problem. Hey, we can stop worrying about this. The natural laws, the laws of nature, work by themselves. And Laplace wrote a book about his findings and his physics, how the world works. He was very confident about that he had described everything correctly. By the way, now we say that his findings about the stability of the solar system were not quite right, but that's another story. But at the time, it was viewed as the answer to the Newtonian quandary of a unstable solar system. Napoleon read the book, and he came to Laplace and said, "Hey, good book here, but I don't see what God does here. Where's God in the book?" And the famous retort that Laplace is supposed to have said, and he may well have said this or something like this, was, "Sir, I have no need of that hypothesis. Sir, I have no need of that hypothesis. Natural laws does it all." Now, Laplace turned out later advocated determinism. So here we have the historical genesis of this idea of determinism. And the way Laplace elucidated it and explained it was exactly the same as the way that people like Sabine Hassenfelder and Jerry Cohn talk about it today. It's this idea has persisted since Laplace, but it started, you can at least trace it back in modern times to Laplace. And he said, yeah, if you had a good enough calculation machine and you had all the information about where all the masses were in this universe, you could predict the future. Everything is determined by the laws of nature. Everything works according to the laws of nature. It goes back to Laplace. Now I want to remind you of Thomas Burnet, because this determinism of Laplace was all you can find it buried right there in Burnet's greater God theology. And Burnet was influential, and this greater God theology became very popular. He said the greater clockmaker is the clockmaker who makes clocks that just work. The greater God is the God who makes the universe that just works. Sits back and it just works. Well, there is the genesis of the idea of determinism right there in an Anglican cleric's ideas, religious ideas about God. So this is a deep-seated theological idea that influenced science. It called for a God who is a greater God. A lot of history behind this idea, and a lot of religion behind this idea. So it goes back to Burnet and the greater God theology. This is what they wanted. This is what they wanted religiously: determinism. It's an example of how religion drives science. So now we have this determinism idea still around and being advocated, at least as strongly, if not more strongly, than back then. And the absurdity of it is all the more obvious, as I've indicated in previous videos. I've talked about the different problems with it, both philosophical and both scientific, from neuroscience, epistemology, creativity. I've talked about the empirical evidence we have from free will. These ideas just demolish and show the absurdity of this idea. And one of these evidences was the creativity problem that I mentioned. This do we really think that all the works of Beethoven were created by the laws of gravity? Come on, this is ridiculous. Laws of thermodynamics and electrostatics, these created the works of Beethoven. The same argument, by the way, applies to the natural world. This isn't just the creativity of humans. You can look at Beethoven, you can look at the bumblebee, you can look at any number of examples in the natural world that make Beethoven's work look trivial. The bumblebee alone dwarfs Beethoven's works. So the same thing applies. The idea that the natural laws, the gravity, electrostatics, etc., could create this world is not a scientific idea. It's a religious idea. And that's the history behind this that can help you kind of get a bigger context to grasp the importance of theology and religion, how it is driving the world that we're in today, and especially science. So until next time, religion drives science, and it matters.